Thank you for joining us this evening and for the invitation to come and speak about our experience and the design for the Shanghai Tower. My name's Grant Euler. I'm a principal and architect with Gensler. I work out of our Chicago office, but I spent quite a bit of time in Shanghai during the design and construction phase of the Shanghai Tower. And to my right is Randy Reeves. He's an associate with Gensler here in Detroit. You've been with Gensler for how many years?
15 years, and I also spent 8 months in Shanghai working on the project as an architect.
And he's a graduate from LTU.
LTU graduate.
Yeah.
Thank you.
So we have about a 40-45 minute presentation that we want to go through, and then we're going to open up for some question and answers. If there's time, we have a short video at the end of the presentation, and then we'll take other questions in smaller group format out in the gallery space just outside the auditorium. So there's a series of models and things there. But to really just get started, the first slide here is just quickly about Gensler. Gensler is an architectural design firm that was founded in San Francisco 50 years ago this year. This is our 50th anniversary, and the firm has grown globally. We have over 5,000 staff in 40, I think it's 46 offices now. And many of the most recent additions are in Asia. We have 9 offices in that region, and Shanghai is the regional headquarter office of that region. One of the things that we do within Gensler, a large firm, is we share resources back and forth to align the talent and the opportunity, and so the benefit to Randy and I and others to live and work in Shanghai was really just amazing.
Okay, so back in 2008, Gensler won a competition to design the tallest building in China, which would be the Shanghai Tower. With over 24 million people, Shanghai is China's largest city and one of the world's most populous cities.
Excuse me, I think we need to fix the lighting.
Yep. You can turn off the lights in the front.
Let's see if I can.
Yeah.
Just turn off the front.
Closer.
Closer.
Yeah, this is better.
Yeah, that's much better. Thank you. Okay, so Shanghai is divided by the Huangpu River, which you can see flowing down the middle of the screen. And the Huangpu creates 2 districts in Shanghai, with Puxi district to the west and the Pudong district to the east. Back in the mid-1980s, China's central government designated a portion of Pudong as a special economic zone, opening it up to foreign investments. At that time, Pudong was no more than swampy agricultural land with low-rise, low-density housing. You can see this is actually the view from Puxi over the Bund. The Bund is in the foreground. This is the area that was opened up to the embassies, and then the area, what we call Pudong, is across the river, and you can see right where the river bends. So take note of this. This was back in 1987. And like I said, that's when China's government opened this area up to foreign investment, and we all know what foreign investment can do. So skip ahead 26 years. 26 years later, Pudong has been built up into a modern skyline, becoming the new central business district for Shanghai. The master plan would call for a new business zone that would include the world's first super high-rise district. 3 new towers would be erected that would represent not only the new central business district, but a cultural landmark as well. And it's quite a transformation in just 26 years. So when we say tall is a relative term. Shanghai Tower is 632 meters tall. That's 2,073 feet above grade and another 85 feet below grade. It's almost 3 times taller than the Renaissance Center in Detroit. And you can see the image here for scale, which is an actual 2-scale image. Shanghai Tower has more than 125 floors and encloses 6.2 million square feet above and below grade. To put that in perspective, the Renaissance Center, what you see here, is approximately, I think, 1.5 million in the office towers.
One of the underlying concepts of the building is you envision this tower in the city, in the upper right diagram. And certainly see that with the density in the Pudong district. We looked at it as the city in the tower. And Shanghai, if any of you, how many people have had a chance to travel to Asia or to China? So it's quite a number. It's an amazing city, a very large global city, but it's amazing with a series of neighborhoods. And so what we looked at doing, and these are some of the sketches early on, was essentially take these linear neighborhoods, every block where you have coffee shops, flower shop, restaurants, people are out having dinner with their family out on the street. Take that on its end and make that vertical city where there's areas of rest, there's sky gardens, atria, which we'll talk a little bit about in the future, are coming up in a few minutes. But the idea of taking this linear link and making it a vertical city, something that's extremely sustainable, very dense, very compact. This carried through into the rest of the design.
Yeah, one of the interesting concepts, or one of the interesting things about the concept that really shines through, you'll see this in a couple more slides, is how the pattern of the city and the rhythm actually informed us to what the city, or the vertical city in the Shanghai Tower might look like in terms of the actual layout.
These are the three towers in the Pudong district, part of this enterprise zone. And we refer to the three towers as the past, present, and future. The building that looks like a pagoda in the center there is the Genmao Tower. The one to the right, my right, your right, my left, is the Shanghai World Financial Center. That's really related to foreign investment. It was a Japanese developer and investor, and that was China Present. That opened in 2008. And then the Shanghai Tower, which is the tallest of the three brothers, but also the youngest. So there's some interesting dynamics of the three. And it was really looking to China's future on the global stage. Part of this harmony, and these are some technical drawings that explain the concept, is the idea of this exponential height. It's not just a simple stair step between the three towers, but each tower is exponentially taller than the other. So it has this sweeping form in the red line there. And that also allowed us to dictate the taper and the twist of the tower. It's a very elegant solution where this tower tapers as it rises and then it twists as well. And there's a variety of reasons for that. It creates on the skyline and in the neighborhood in Shanghai, there's not a front and there's not a back. The entire building is a front. It's for the people, it's for the country of China, and so it has very good feng shui. And it also does some amazing things from a structural standpoint, lowering wind loads, et cetera, which we'll talk about shortly.
Yeah, that's, I was told this slide was going to be boring, so I had to add something to it. So that's what I added. That's one of my pictures. When I was shopping at the Tesco in my neighborhood, they sold bimbo bread, so I had to go to the supermarket and pick up some bimbo.
It's bilingual, though. I can see it's...
And the interesting thing behind that is that is actually a Mexican brand.
Very, very global bakery. We talked a little about the twist and the taper. We looked at a variety of different forms, and we found that the 120-degree twist, or essentially 1/3 of a circle, was the optimal twist, and it was about a 55-degree taper. And one of the things in super tall buildings, from a structural standpoint, you have to design them for seismic, earthquakes. You have to also design them for wind. And in this case in Shanghai, at this height, the wind becomes the driving factor. So you have to design a building that withstands the wind. And what we did through a concept called Vortex Shedding, similar to an airline wing, is with the twist and taper, this wind curls around the tower and creates these eddies on the backside, which actually reduces the amount of stiffness that you need to design into the structure. So we were able to reduce the number of tons significantly and also reduce the construction cost by just under $60 million by incorporating that taper and twist.
So we have this cloak, this glass curtain wall system that tapers and twists as it rises out of the ground. And Grant just mentioned that the taper helps it to withstand seismic and wind loads. And this is actually done on an exponential curve rather than a linear curve. We did some testing and used some bases of known buildings, such as the John Hancock Tower in Chicago, which would have a linear taper where it's a single line. This actually has a more of an exponential taper, so it tapers less and less as it goes up the building. And one of the interesting anecdotes is that our BIM manager actually was talking to his wife and explaining this situation and trying to figure out an equation that would actually come up with, that would meet the requirements of this taper. And she, being an accountant, said, well, it sounds like you're describing this formula for this particular way to compound interest. And we took a look at that, and certainly enough, it worked. So we used a financial equation to actually determine the taper of the building. So the building is comprised of 9 stacked zones, and 10 if you count the one below grade, each becoming successively smaller in diameter as they go up, not unlike a tiered wedding cake. The cake is then wrapped in a cloak of clear glass, which twists and tapers as it rises out of the ground. The cloak is a rounded triangular shape with a V-notch taken out of one corner. It's called a strake, and that is an aerodynamic feature that helps to reduce the wind load on the building. The building has no spire, and the curtain wall extends from grade all the way up to the top. If you remember a couple slides back where we had the different comparison of the different buildings, as you can see, most of the buildings on this have spires. Ours is one of the few that does not. If we look at the Burj Khalifa in Dubai, the top 100 meters of that building is a spire. So think about that. It's a 300-story building, 300-foot tall building of spire. We do not have that in our building. So we are the second. So most of the 9 tiers of, each of the 9 tiers of the wedding cake represents a zone. Each zone has about 15 or 16 stories, including 2 mechanical floors. And the zones are dedicated to banquet, retail, office, hotels, and observation. Each of the zones are served by dedicated high-speed double-decker express elevators, and the observation elevators are the highest and fastest single-run elevators in the world, traveling at more than 40 miles an hour. At the time when we were interviewing elevator consultants, or elevator contractors, providers, and manufacturers, nobody had the technology to actually do this. The one company that stepped forward was Mitsubishi. They said, if you give us the contract, we will develop the technology to design this elevator. They got the contract. Oh, actually, I want to explain a little bit what's going on here in this image. So the system at every, the curtain wall system is interrupted at every zone, every mechanical zone. You can see over here, and we have 2 floors of mechanical, and then the double skin envelope actually creates atrium spaces at the bottom of every zone. And this is about a 14-story atrium, and we have several of these going up the building. This diagram is actually the curtain wall system, the exterior cloak, unfolded, and we can see some of the wind pressures in the different colors that are applied to the curtain wall system. As part of our overall design, you know, we are designers, we design everything that we possibly can. We designed the frit pattern that also provides shading on the glass, and for the frit pattern we actually use the footprint of the building. The double skin envelope is created with a unitized system, meaning that the individual panels, which there are more than 12,500 different sizes, comes out prefabricated, and we just hang those on the building. And each panel actually has a little bit of a roof that you can see here, and this is how we achieve the taper of the building. All right, so the space within the double skin envelope is a large atrium. And the way that the building is shaped with a circular wedding cake inside of a triangular cloak creates 3 large atriums per zone. The atriums are about 13 stories tall and serve as amenity spaces for the building's occupants, giving them a common space where they can meet friends and relax outside of the office without having to go all the way down to grade. And the rendering on the right is one of the upper zones, one of the upper atriums. We can see the tops of the 40 and 50-story buildings that surround the Shanghai Tower. And these are two actual construction images looking up, 14 stories up into the atrium. And this was probably taken about a year and a half ago while the building was still under construction.
These are a couple images of some of the interior lobby spaces. The one on the left is the ground floor lobby for the office tenant. In the lower right is the lobby space adjacent to the retail. And then Shanghai is populated very densely with these beautiful boutique shops, storefronts. And so the idea of taking that metaphor and wrapping that into the retail spaces of the building was one of our design concepts that's carried through. The challenge, one of the challenges of a super tall mixed-use building is just moving people in and out. This building has over 100 elevators, I think 106 lifts. Many of them are express lifts that are double-decker, so 2 elevators stacked that race up efficiently up to one of the sky gardens, sky lobbies, and then you depart from those elevators and get on a local lift to go up to your floors. And so the idea that once you're there for the day, you can have lunch, you can take a break, you can stay within that sky garden and not use the energy or take the additional time to get back down to the ground. So you're really trying to optimize the performance of the building and the energy use as well. A couple other slides on the interiors. This is the hotel entrance. There's a hotel in the stack, which Randy will speak to in a few minutes. And then the other office entry here as well. So much like up in the sky with those sky gardens, we have a similar component here. These are about 6-story in height, an inner skin and outer skin. The one on the left will be populated with a series of restaurants on levels 2 up through 6, adjacent to the retail space. And just a very elegant, inviting, daylit space, again, using that energy performance.
So we've incorporated several sustainable features into Shanghai Tower, including wind turbines to create electricity, rainwater harvesting, gray water collection, both of which are used to flush toilets, geothermal heating and cooling, and a building-wide recycling program. The tower will be LEED certified gold when opened. In this image on the right, you can see the crown of the building and some of our wind turbines, and those will create enough electricity to light the building at night. I think actually that was one of yours.
No problem. So this is a simple graphic that shows we're able to save about $2.5 million in energy savings annually. And these are the various components. So obviously just the central plant and using the HVAC system, there's considerable savings and efficiencies with that system, much as which Randy just spoke to. The envelope with the high performance exterior are able to save almost $200,000 in energy use a year. And then lighting controls. The wind turbines at the top actually can generate enough electricity to light the exterior of the building. And so there's considerable savings with that too. All of these things add up together to get that LEED Gold certification and lowering energy use by 21% of a similar type building. These are some structural diagrams. Thornton Tomasetti was our structural engineer. Their New York office and the Shanghai office collaborated together on. And essentially, it's very complicated, but it is a very simple structural system. We have reinforced concrete core, building core that rises all the way up through the building, link beams, which are shown in yellow, that tie that concrete and steel composite core together. Outside of that, we have super columns, which are shown in the blue. And these are a good metaphor that Randy reminded me of earlier today, is that much like a skier, if any of those snow ski, your body is here, and these super columns are really the ski poles. And then my arms become these outriggers that sort of brace the tower from this wind element that you need to design for. And those are all tied together by these steel belt trusses that occur at the bottom of all of those atrium spaces. So it really creates kind of the belt and suspenders, if you will, around that system.
And to Thornton Tomasetti's credit, they were able to contain all of the diagonal bracing in the building to the mechanical cores.
So again, in the upper left here, the core, and as the core goes higher, there's less need for elevating, less need for mechanical spaces as the floor plate's becomes smaller. And so that core steps back, creating this wedding cake reference that Randy mentioned. The next slide or next image is the outriggers and the super columns. They're tied by these mechanical floors that link to the exterior skin at every 12 to 15 floors. Then there's the inner skin, and then there's this outer skin that ties it together. So really 5 systems in place. That's an exploded axon of the tower crown. See, and it's very much a mixed-use component of the building. You have the crown at the top, which is where we house the cooling towers for the top, really top probably third of the building. We also have the tune mass damper, which Randy will speak to in a minute. And then we have 3 levels of observation deck, including an outdoors space for observation, which is the highest observation deck in the world. And there's also restaurants. And then below that space is the hotel.
Randy, you're going to have to explain your center slide there too.
Well, you know, one thing I miss about China the most is the food. And you know, sometimes the translations are a little off, but equally interesting.
This is a photograph of inside one of the office spaces. Just to show you these super columns. And at the base of the building, they're essentially the size of a small apartment or a conference room at about 17 by 14 feet. And then they get smaller as they taper up to the top.
So the little concrete structure is going all the way to the top of the building?
Yes. It stops just below the crown and below the cooling towers.
Yeah, it stops right here. Okay, so the next series of slides are, we're taking a look at some of the computer programs that we use to help design this tower. We actually used a large number of programs, and there were some programs that we actually had to learn in order to help design this tower. And this was particularly one of them, and it's called Generative Components. I don't know if anybody's heard of that or has used it, but we learned to use this program in order to help us document the complexities of the twisting and turning curtain wall system. So I got a couple slides here, just kind of flip through. Some people it may make a lot of sense, other people maybe just your eyes will gloss over. But so we used Generative Components. We also use Rhinoceros. I'm sure a lot of people, or some people may use Rhinoceros here or Rhino. But we use a series of models and parametric modeling to actually get the form, and not only to get the form, but actually to modify the form as well. I mean, we did a lot of studying in what it means to actually, you know, what happens if we turn the building an extra 1 degree? You know, what happens if we taper it just a slightly, you know, slightly more or slightly less? You know, what does that do? I mean, this is, you know, pretty heavy computing power. And these programs, Generative Components, Rhinoceros, and Grasshopper, all let us take a look at this in a very quick mode. The study models were also great, and this is what we look at out in the gallery space. They were rapid prototyping, and those also let us look at our concepts in a built environment. So here we can see the series of these drawings. You can see the floor plates as they twist and they turn as they go up the building. And the parametrics was very big in this, in the design of this. We had a couple guys that were experts in modeling like this, and these are some of their screen captures. So we modeled everything start to see. I believe this is still Rhino.
This is actually the curtain wall supporting structure that supports that outer skin, and coming up with an engineering. Essentially, it's been referred to in like a bicycle wheel with the spokes coming out from that central axle out to the perimeter, and that holds the outer skin. And it creates this really beautiful matrix of form and shape and shadows in these sky gardens.
And I'm sure somebody recognizes this. I kind of know what this image is of, but I couldn't explain it to you other than that this is a lot of different functions linked together. And when you plug some numbers into this, you get some really cool output. And I believe this is Grasshopper. And one of the great tools, one of the great things that we can do with the BIM modeling, the building information modeling systems, is coordinate with our consultants. So we had several consultants working here in the United States and in Shanghai. And what we would do is every week we would have them upload a model, and we would take their models and overlay them with our model. And we could see where the clashes were occurring, where we had room, where we didn't have room. But this is one of the mechanical floors kind of higher up in the building. But we can see all the mechanical systems with all the piping, the ductwork, the plumbing. We see the structural system. This is the belt truss. And actually at this point, this was a double belt truss. This two is better than one. And all the spaces that we need, all these elevator shafts, everything is modeled in here. And we can kind of go in and determine where we have clashes, where we don't have clashes, and where we need to spend a little more time. So it was a great coordination tool.
Okay, if you go back to
Certainly.
Thank
Two.
you. One more maybe. Yeah. So you know, part of the opportunity when you're designing a complicated building like this is that there are a lot of different parameters and variables, and one is the elegance of the taper and the twist. From a planning standpoint, those of you that are familiar with floor area ratio or site coverage or some of the different components of architectural planning and site design, is obviously we want to maximize the amount of square footage that you're allowed to design and to build. And so when you're tapering and when you're twisting and when you're removing space to create these atrium, you're giving back available floor square footage that they could build and lease as a hotel or as an office. And so that was one of the parameters that we were constantly managing, is maximizing the allowable square footage that you're able to build, in addition to many other things. So some of the variables that Randy spoke to related to that: square footage, site coverage, setbacks, etc. Thank you. You know, amazing experience to work on a project like this, the tallest building in China, second tallest in the world currently. Another equally humbling experience is just being in residence in Shanghai and living and working with this team. These are some shots of our team, very much a global, international team. Individuals working, this is our work environment in the upper right, so obviously we're not lacking paper and models, and some of the models you'll see in the gallery are also in this photograph. And we had a team of about 150 people in total working on this project, including about 35 to 40 consultants from around the world. One of the things that my role as one of the project directors was really to make sure that all the team members were on the same page, and communication, and with the language barriers and with the time zone changes around the world. We found that in the space, having this pinup wall was just phenomenal. Maybe you do some of this in your studio spaces here as well, where you may be working on a specific part of the project that you need to own and really lead, and not aware of the other 2 or 3 dozen things going on. So we pinned all this up and changed that weekly, so you could check in and ask one of your colleagues, what are you working on? Floor plans, elevatoring diagrams, exterior skin studies, looking at project scheduling and what the next milestone issue dates were. Just really amazing experience. We had our 5-day work week, Monday through Friday, and then we had our 2-day work week, which was Saturday and Sunday. And it was very rigorous work to meet the schedule. It was 2 years for a design phase is very aggressive, and we were able to hit that milestone in order to maintain the construction schedule that the client had set for us.
Sure. So this is near the start of construction, and what we're looking at is the hole that was created to build Shanghai Tower. So you can see all the workers wearing their blue outfits and their yellow hard hats, just to get a really good idea of the scale this excavation. So this would be the top of the mat slab. And this slab is actually 6 meters thick of concrete that was poured in one continuous pour over 60 hours. This slab was actually poured on top of several piles, I think in the neighborhood of 2,500 piles that were driven, I believe, 75 meters below this level. We can see the rebar coming up, and this is actually the framing of the core. So we can see the big square of the core, and then the square of some of the shear walls coming out, and then also the super columns where they're actually going to be anchored to this mat slab. And basically 5 levels below grade, the 3 lowest levels are parking, and then the 2 upper levels are retail and other mixed use.
So the foundation, I'm sorry, I couldn't get that. The foundation was even below this bar, 75 meters below the ground, or that was the main foundation?
Yeah, this is the main foundation of the building. It's at about 25 meters. The top of this rebar is about 25 meters below grade. And the piles below this go down about another 75 meters, or 50 meters actually, sorry.
So when you decided the space or the exact area where you want to build the tower, I'm sure you looked at geographically or geologically the ability of the ground to hold something like that. Sometimes you have high water level.
Yes.
Other time you have clay modeling, you know, that things can hold the structure. What were your challenges for this?
So we had 2 buildings across the street that had gone through similar. So obviously we did a lot of soil borings and geotech and looked at the most appropriate solution for a building of this height. The water table, the sand, silty clay, soil was certainly a condition. These are the piers or piles are friction piles. So it's not, they're 75 meters deep. But the bearing capacity is from the side, the friction of those fingers going out at the earth. It's not what they're landing on. And so that, the 2,500 piles creates that friction, and then you have all these sort of toothpicks poking up, and then this mat foundation that's almost 20 feet thick is poured on top of that, and that pulls it all together, and then you've got a foundation to build from. That was the system that was most appropriate for this building.
Okay, so there's another construction shot, one looking up the atrium. We can see the spokes of the bicycle wheel that actually provide the lateral support for the curtain wall system. And then we have these, that's kind of hard to see, but in here we have these sag rods which actually take up the gravity loads. The curtain wall systems are a true curtain wall system in that they are hung from every zone. So starting here at the mechanical zone, from this point down, this curtain wall system will be loaded from this point. So loading structure in tensile or in tension, you get a much smaller member, smaller curtain wall framing, smaller structural members. So this actually helped us to create a more transparent curtain wall system. And another shot, this was taken from across the river, of course. And you can see more of the framing, more of the curtain wall system going up. These 2 slots are for intake of air and exhaust of air. So we don't have any louvers on the exterior of the building. We actually incorporated these 2 continuous slots, and actually one of them actually does double duty and provides access for the building maintenance equipment, which is like the window washing, and if they ever need to maintain the exterior, when they need to maintain the exterior of the building, it's actually supported by some rig that actually pokes through this slot. It's pretty amazing. I'll explain how it happens when we go out to the gallery. All right, so the observation deck is the highest observation deck in the world, higher than Burj Khalifa by about 40 feet. The observation has 3 levels, the top of which is a restaurant. And when you're upstairs, one of the levels is actually outdoors, so you can actually experience the outdoor air at 1,826 feet up above grade. So there's going to be a pretty big temperature differential. At times, the top of the tower will be in clouds, and the temperature differential will be very noticeable. On the day that this image in the lower right corner was taken, we could see ice forming on the stairs. And at the grade level, it was a fairly comfortable day. It was probably a little warmer than it was today here. And upstairs, we have all this ice. Now, one of the interesting things about here is walking down the stair, a steel stair with ice on it, and if you slip, what do you grab on to? This beam, and then there's about a 90-story drop on the other side. So construction conditions there were a little bit different than what the OSHA standards that we have here in the United States.
Remember being up at the top with, without the exterior wall on, really the clouds are just blowing right through the building. You're up in the clouds. And so being aware of the temperature change and the thermal change of materials, how things expand and contract, very much was part of our design process. Thinking about how that exterior glass expands and contracts with the different climate change at different heights in the building is something that's really important to work through.
Range of the swing.
The building is designed to move, as most good tall buildings will be. And our building is designed to move about 28 inches off center from plumb. So at one point if there was a seismic event or a very windy day where the winds actually change direction, you could actually move 28 inches off of center in one direction and then move 56 inches in the other direction.
That's very, as Randy mentioned, very common for a period of a building to move back and forth and sway. What you want the design for is for human comfort, and so that acceleration you want to be very slow. You don't want it to be quick, you'll feel that, but if it's very gradual, it's undetectable.
28 inches out of plumb.
That's actually quite reasonably small given the size of the building.
It is. Yeah, we designed, we have actually a tuned mass damper at the top of the building, which is controlled by eddy currents. So basically large magnets and copper plates will move this weight around to reduce the acceleration of the building. And so as we all know from physics, acceleration is different than velocity. And once you reach a certain velocity and you maintain that velocity, you really don't feel the movement. It's the acceleration that you feel, either accelerating, speeding up, or slowing down. So the tuned mass damper acts as a buffer to reduce that acceleration. And as a result, it also reduces the amount that the building sways. So on this day, me and my colleague Fred, who we now call Fearless Fred, we actually had an opportunity to go up to the 93rd floor. And this is the picture, the top of the tower cranes are actually in the clouds. But on the picture on the left, there's an arrow pointing to the rig that we actually got to climb out on. And this is kind of a rusty rig, and when we climbed out onto it, our guide told us to step only on the beams and not step between the beams. And we can see how rusty this is, and basically that's just 2 layers of very thin expanded metal lab. And it did move around quite a bit, and Fred was not afraid at all. He actually went to the edge, this unprotected edge, 93 stories up, and took a picture over that edge. We were yelling at him, get away from, because it was pretty windy, and Fred could have been blown over, but thankfully he wasn't. All right, on a clear day, the tower will be visible for about 50 miles away, including most of Shanghai, depending on your elevation. The image on the right is from my 32nd floor apartment in the French concession area, and that was taken 2 years ago. And that was about 5 miles away. The image on the left was also taken from Puxi, about 3 miles away. So this is going to be a tower that, as long as you have enough elevation or the right vista, you're going to see this from a long ways away. So after 6.5 years of construction, Shanghai Tower will open later this year. It's more than just a tall building. It's a vertical city and a cultural icon that represents the daring and ambition of a modernizing nation. It's also a great example of how a building can transcend its materials and construction to become a true piece of architecture. Thank you.
Thank you.
Time for a couple questions?
Yes.
There are people
Sure.
Play those. Are there any questions? Assuming I can get them. There we go.
Well, fascinating. Thank you for great work. Who is funding? Is it a government project or is it a privately owned project?
The ownership is 3 entities. One is a government-funded financial component.
Right.
The other is the landowner, that they owned the land prior. And the third is actually the construction group. So the three of them have come together.
So
Yes.
what is the total cost to put it together eventually?
It's just over 2.1, just over $2 billion US.
2 billion.
2 billion.
Out of our reach.
But we save $2.5 million a year on sustainability.
Yeah.
So there you go. Now, is it in our reach now? No, still not. All right. Other questions? Please.
What is the biggest surprise you didn't expect at all during the construction or design? Pleasant or non-pleasant?
Part of the experience, and I found to be very patient, was beneficial, that consensus building and making decisions is different culturally than it is here. It's not right or wrong, it's just different. And so being very patient to work through those design decisions and making sure that we maintain the project schedule took quite a bit of time to sit and kind of work through various design options and approaches and approvals.
So it's not technical.
What was not technical, one of the technical challenges was that our client said, we've hired Gensler to give us the best building that can be done. And so we want you to use your global experience and best practice around the world, the most international building codes, what's happening in places like in the US and in Europe. And so we would push that, those international best practice related to seismic code or related to fire, life safety. And then we'd meet with the local jurisdictions and they would say, well, that doesn't meet the current code. And we said, it exceeds the code, it's something better. And they said, no, you have to meet the code. So we would have to meet the code and then continue to work through this expert panel review, again, consensus building, to elevate above that current code. And it was very challenging. What's beautiful right now is we're working on other projects in China, and now they're looking at the Shanghai Tower as the model code. So we've kind of come full circle on that. But that's something I wouldn't have anticipated. Amazing experience technically to work through that. Good question.
Other questions? I'll come to you.
Do you know how many people
Or I won't.
the project in terms of design and how many man hours it took to make it?
The team, the Gensler team was about 150 people from 8 offices. Randy and myself and about 30 of us were in residence in Shanghai. There's 168 hours in a week, and I worked many of those, so it's really hard to estimate total man hours. A lot.
Yeah.
Whole bunch of man hours.
Questions, and please do wait for me so that we can get it on the feed here. I'm trying to post this. And if you could do your best to raise your hands from across the auditorium so I have to run back and forth. You did fabulously well. Helen.
We do have a video.
Okay, I guess my question here is this building seems to have a pretty heavy emphasis on sustainability, and I guess what I'm trying to get at is, well, we haven't really designed anything that would be close to an actual arcology. Would that be what you were trying to incorporate into this, or just like going for as sustainable as possible?
As a firm, we always look to design our design to be environmentally friendly, and that's one of our principles. And on this project, that went hand in hand with the client's or the government's will or desire to actually have a sustainable building. So they were more than on board with us making a lot of sustainable moves. The building, we certainly went for LEED Gold, and we're going to get LEED Gold. China also has a similar program. It's called China 3-Star System, and we are going to be 3-Star System certified as well. So this is something that the government is looking at being more than just another tall building. They're looking at this as being something that represents their future. So they were more than willing to shell out a couple extra bucks to make, or yuan, to make this a sustainable building.
They really want to see this being a building for China's future, for global, for the ecology, for the environment. There was a question about height and being the tallest, and we're really looking to do with this Shanghai Tower project and building is make it the most sustainable, urban, super tall building that's out there, and it becomes a reference for other designers and other clients looking to do this around the world.
There's a question back here in the back. I can understand why there's so much emphasis on the shaft, but can you talk a bit about what happens at the ground?
Sure.
Yeah, so in the image on the right, at the base of the building is a 5-story, actually a 6-story podium building, which obviously has the entry points and the security check-in points for the different uses of the building. Within that 6-story building, the first 4 levels above grade are retail, food and beverage, restaurant, specialty retail, amenity spaces for the over 20,000 people that will work in this building on a daily basis. On the 5th floor is a large auditorium conference center facility, again, that the hotel can rent and operate from their amenity spaces above. It also becomes a great showroom meeting space. 2 levels below grade, as Randy mentioned, is additional retail spaces and amenities for the tower. And for the project. There's also a subway station that was designed at basement level 2. So a lot of the people circulation flow in and out will come from that subway. And then there's parking as well below that, 3 levels.
I have 2 questions. The first is the 8 offices were located, where were the 8 offices located? And the second one is, what was the most challenging part of the construction itself?
The 8 offices are really set up in a series of zones. So again, in the image on the right and the image here in the center to my left, in between those bands are what we're calling zones. And so right above that podium, retail, restaurant level, are a series of 5 zones for office space. Each one is 12 to 14 floors in height. And then the 2 zones above that is the hotel zone. And then the zone at the top of the building is that observation experience zone. It's a good question about the most challenging. I mean, there was days when things were really challenging. How are we going to get this done? But I think our capable team and our can-do attitude and just the challenge of stepping in and taking on something of this enormity was just really exciting.
Any other questions?
Okay.
Yeah, we do have a 4 or 5 minute video here if we would like to run too when we get a chance. Maybe one more question?
My question is, when coming up with the design for developing the structures and everything, did you take any inspiration from the Chinese culture and from the Chinese environment, or were you going for more of a timeless building design regardless of the geography and where it is located?
We did take some of the cultural cues from the regional culture. One is, Grant mentioned, the feng shui of buildings have a front and a back, and this building truly does not have a back, so it's never turning its back on anybody. The idea or the practice of feng shui is very prevalent in the culture here. So we actually had some design moves that were implemented to address those concerns.
The concept of this layering, that the Chinese, the families are very, very tight, very insular, very supportive of each other, and then as they work their way out to the street, many times you'll see families, multi-generations dining out in the street in these neighborhoods in Shanghai under the sycamore trees, and so this transparency and this openness and is willing to share and connect with the community is all about this double skin and these atrium spaces where you can look in to this building from the street and see people up in those sky gardens. When you're up in the sky gardens, you can look out and connect with the people. So it's very much transparent. It's very much the new China. It's very much forward-looking to be open and expressive. And this is a testament of that in the design.
think more questions can be had out as we return to the gallery, but before we go there, I want to thank you both for coming on behalf of the university and the college.
Thanks for the opportunity.
A small token of our appreciation. There it is. So we go to the gallery space.
Thank you.
both. Thank you.
Thank you all. Thank you.
Yeah, no problem, Scott.